During the cooler months of the year, at higher elevations, snow accumulates enough to allow for downhill sport enthusiasts like skiers and snowboarders to enjoy some runs at their favorite ski resorts. During the 2022 season, U.S. ski resorts saw about 11.6 million visitors. Also during that season, the ski and snowboard industry brought in over $60 billion to the U.S. economy. However, the highly lucrative industry does come with a high price tag to enjoy a day on the slopes. Passes like Icon and Epic offer bulk deals to help alleviate some of this financial burden and allow for multiple days on the slopes across resorts worldwide at a flat rate. Ski and snowboard enthusiasts are drawn in not only for the adrenaline and the natural beauty of the mountains, but are often greeted by amenities within the ski resorts, such as restaurants and bars, along with essential services like stores and medical centers. This is a weather-dependent activity requiring the right conditions for snow accumulation, and climate change and rising temperatures do pose a threat to these conditions. Although snow is the main weather attribute that is going to be examined in this analysis, other characteristics such as wind speed and visibility are also important. There have been at least partial closures of ski resorts due to high winds and low visibility. Top priorities of this analysis include creating an interactive platform to report results, obtaining data through a programmatic approach such as using APIs and minimizing single-use code, all in an effort to explore the weather trends, business trends, and opportunities, as well as any regional separation contained within the data. Building from the idea of a programmatic approach to this analysis, such as using APIs and web scraping libraries, some of this data was hard to come by and required considerable web scraping and cleaning. Ski resort data had to be complete and precise to align better with the weather and business data surrounding the ski resorts. Weather data was expensive in terms of acquisition, as it had to be complete across both spatial and temporal scales, and complete in a sense of variables required for potential snow prediction or other weather phenomena. Complete business data across several different categories also had to be found and be accurate to the location. Ski resort data was compiled through several different sources using web scraping and required mostly dropping columns and combining columns to clean it. The final result was a complete data set of over 300 different ski resorts across North America, inside the United States and Canada, with location-specific information of the ski resorts as well as rating information and other secondary location types. Weather data was compiled through the Visual Crossing API and required mostly outlier handling during the cleaning process. The final weather data set was very similar after dropping some outliers and dropping columns for variables only available at certain locations. Business data was compiled through the Google Places API and required a considerable amount of cleaning to be used within an analysis. The final business data set included resort names, coordinate-specific locations, ratings, and categories for the businesses. Snow, being the main phenomenon of interest, was examined first. It was found that Icon Pass resorts generally received more snow in North America, and resorts in the U.S., especially the West region, received the most snow of the resorts. Furthermore, regions which in general received more snow also generally had higher rated resorts, with the West region in the United States and the West Coast region in Canada trending towards the higher rating side. Within the clean weather data, the variables available in their respective ranges were analyzed. This process not only aided in outlier detection, but also gave insight into the quantitative characteristics of the weather attributes. Variables such as temperature, precipitation, pressure, and humidity are important conditions required for snow. And variables like wind speed and UV index are important for mountain goers to consider. Next up, the amenities such as the business categories were explored, and the associations between the categories were analyzed. All main categories of amenities were linked to points of interest and establishments, not surprisingly. However, this also showed a pretty heavy association between most points being associated with stores, health, and food. Additionally, some of the individual subcategories, such as shopping, was heavily linked to clothing stores, groceries were heavily linked to convenience stores, and even financial establishments, spas to beauty salons, and restaurants to bars and cafes. One of the more significant results was exploring past types through decision trees. Epic and Icon resorts, which had a somewhat similar proportion, were used to create a hyperparameter optimized decision tree. Using a testing and training split on the weather data associated with these past types, a model with almost 98% accuracy was created. The model mostly contains splits on weather and elevation attributes. The significance of creating a decision tree using just the epic and icon passes lies in its application for possible expansion into independent or third-party pass type mountains. The decision tree classifies a given independent resort for each month of the year. Then, the percentage of the year a resort was either classified as epic or icon was analyzed. If a resort was classified as one of the pass types, being either epic or icon, a majority of the time, that could indicate a potential expansion area for the pass company. Significant findings were revealed during the exploratory and modeling phases. In the exploratory analysis, it was found that regions with more snow generally had higher rated resorts. Additionally, most resorts had the basic amenities, including healthcare centers. During the modeling phase, associations and relationships were found between the categories of the amenities. Food, restaurant, and bar establishments were highly prevalent at ski resorts. Once again, there will also be likely some sort of healthcare center along with stores, and where there is one business offering, there will always be others. Highly accurate indicators in a logical structure of attributes for suitable expansion areas for both the icon and epic resorts were found. Unfortunately, weather phenomena, like predicting snow using other variables, were difficult to predict given the methods used in this analysis. Returning to one of the top priorities being an interactive platform, a map showcasing amenities surrounding the ski resorts was used within the analysis. It allows for zooming in and even turning on and turning off layers surrounding the ski resorts. The interactive map is part of the entire website experience, hosted at the link at the end of this presentation. The website contains the analysis in its entirety, where more exploration, modeling, and explanations can be found. This presentation only features the more significant results, along with a brief introduction to the topics required to understand this. Thank you so much for watching this presentation, And once again, the link to the interactive website and platform can be found at the website link below, as well as a link to the GitHub repository